This is the ROS Developers Podcast, episode 88.
Developers podcast, the ROS Developers. The ROS Developers podcast, the ROS Developers.
Hello, ROS Developers, and welcome to the ROS Developers Podcast, the podcast that gives you insights from the experts about how to program your robots with ROS. This is Ricardo from The Construct, and today I would like to dedicate this episode to all the ROS developers that are helping to build a ROS and to make it a better framework. Only the ones that are using ROS, but also the ones that are developing new packages, that are maintaining the existing ones, and adding new drivers and dependencies for new robots to ROS. And if you are one of those that are helping to improve and maintain ROS, then this episode is dedicated to you. Today we are going to talk with a person, and we are going to learn how we can, sorry, I have a confusion here with my notes. So today we are going to learn about what are the problems with ROS dependencies, and what about maintaining and improving specifically the ROS ecosystem, and why it is needed that everyone collaborates into that. But before going into that, let me remind you about our online academy that we have that is teaching you about the Robot Ignite Academy. I'm having here a lot of problems. So yes, here it is. Yeah, so let me tell you about our Robot Ignite Academy. It's an academy that we have online for learning ROS, and there you can learn from zero, starting by learning Python and Linux for robotics, and then going into more advanced subjects like ROS2, and of course ROS1 if you are interested, about mobile manipulators, robot navigation, and everything like this. So have a look at the website, because it contains a lot of online courses. And remember that our online courses are based on simulations of robots. So you are practicing while learning all the time from the very beginning. Recently, we have added a remote real robot lab, which is called Robotics, that we have here beside our this office, this room. And it's an online 24/7 lab with a Turtlebot 3 robot, where the students can connect from anywhere in the world and make the robots do and whatever they want, and practice, try their algorithms on the real robot. So have a look. It contains also simulation and so on. So have a look at the website. I will put a link on the show notes. And now, having said that, then it's time that we go with the person who are interviewing today. So today we are going to talk with Sophia Kolak. And Sophia, she is a software researcher at Carnegie Mellon University. In 2019, she presented a very interesting talk at the ROSCON 2019, and which it was entitled, "It Takes a Village to Build a Robot, an empirical study of the ROS ecosystem." Then today, she is here to talk about her paper and why it matters for all ROS developers. Welcome to the podcast, Sophia.
Hi, thank you so much for having me.
My pleasure. My pleasure. So you were presenting at ROSCON 2019, which was in Macau. I was also there, but we didn't meet there.
Yeah, I know. You must have been in the casinos.
Yeah. Yes. You got me. Yes. Yes, very good. Exactly. So I was just for my talk, and then went to the casinos and so on. But it's interesting that I found I was preparing for this interview. Then I found that you had given this talk at the ROSCON 2019. And yes, I missed there, but thanks that we have the recordings provided by the Open Robotics. That's very, very cool.
Yeah.
Okay, so then we are going to talk about this specific talk and also the paper that you publish afterwards with the same title. And then, yeah, so I would like to start by asking you, what is your article, your paper about?
Yeah, so the paper is an empirical study of the ROS ecosystem. Empirical study papers are really common in software engineering research. People do them on, NPM, Julia, PyPy, but there hasn't really been one on ROS. And so we did all this data scraping and built up, all of this infrastructure, and then we sort of analyzed the relationships between various packages in ROS to try and draw insights about software quality and the status of the ecosystem and its health.
And why did you decide to use to select ROS? Why did you selected ROS for this study? Why not others?
Yeah, well, we thought it was really important to have a paper like this about ROS because it is the de facto standard in robotics development. So, it's important to look at the quality and the evolution of the ecosystem because, this is the framework that a lot of robots are being built on. So we need to understand the quality and the security of the packages that are being deployed with ROS.
Yes. Very great. Yes, and that's very useful in order to understand what is happening there, because it's true, nobody has done this kind of analysis in that deep. So just for the people that are listening there, ROS developers out there, I will put a link to the video of her talk, which is a kind of a summary of the paper and also a link to the paper. So you have to watch her presentation and also read the paper because it's very, very cool. And so, in this paper, in this talk, you were talking about package dependence inequality. What is that?
Yeah, so we sort of use that term to mean overdependence on a certain set of packages. So we looked at, the ROS core. We looked at what we call the working groups, packages like ROS-perception or, ROS-motion, all of those. We included all of these under the umbrella of foundational working groups, we called them, just because we saw that these were really commonly used packages. And so we sort of just observed that in ROS, there was a massive dependence on these packages, but many of the other packages released on the ROS distro, the vast majority of them had zero or very few dependencies. And yeah, this is not especially uncommon for software ecosystems, but it was pretty extreme in ROS and limited to a very small set of packages.
Okay, yeah, so it's there are just a few set of ROS packages on which all the rest of ROS is depending on, right? So it's like this core which is maintaining as a dependency on the others, on the rest. Okay, and then, so what does this mean? When we have this situation, what does this mean? It doesn't mean that all the ROS developers are developing everything in their packages by themselves and just calling to the ones that are in the ROS core. Does that mean that?
Well, not necessarily, right? Because you can have a package installed somewhere that you use, like for instance, a runtime dependency that isn't actually specified in your package.xml file. So that could be happening. I'm sure it is. But for the most part, we took the data that we could scrape from looking at all of the package metadata as a pretty decent proxy for what people are actually using. And so while these external dependencies certainly exist, I would say that the packages that are popular are going to show up in the package.xml files over this very large data set that we collected. Yeah, so I don't know if it's necessarily, sorry.
Yeah, but I can tell you why we don't have that for example, in the runtime. We don't have those dependencies specified because it's a pain. it's a pain to do that. So you are struggling with your robot doing something useful, and then you have to take care. So we take all the shortcuts for dedicating the time to the thing that we actually want to. And that, I think, in my opinion, this is because we are not software developers. We are engineers from mechatronics, from robotics, electronics, and I don't know, communications. And then just a few of the ROS developers, they are computer scientists. And that's why we need more of computer scientists to dedicate to this, because they are going to put some order and say, hey guys, yes, that's very cool, but please start doing things properly.
Yeah, no, that's sort of one of the main points of the paper, is that there are so many subdisciplines of robotics. There's, you know, mechanical engineers, electrical engineers, there's AI people, computer vision, and there's so many different things that have to coalesce to sort of like get to a complete robot. It's already so complicated that the sort of software engineering details that are really the emphasis of other ecosystems like NPM or PyPy, whatever, they're really just pure software. So your whole problem is just, how do you get all these people to collaborate, and how do you do versioning, et cetera? But in ROS, there's so many other levels of problems. So it makes it, you know, less of a priority oftentimes.
Yes, and it's a pity, because also it also happens with the documentation. So
Yeah.
you get many packages, super interesting there, but so complex that you cannot know how to use them because nobody has written anything. And
yeah, I don't remember the number offhand, but at one point we got the length of every README in for all the ROS packages, and it was either 3 or like 30. It was nothing, especially considering the complexity of some of these packages.
Yeah.
And I know there's the ROS wiki, but a lot of packages don't even have anything on there.
Yeah.
So.
Yes. Yeah. Probably is the default lines that whenever you create a package and there is the README or Git repo, then the README is auto created, and then maybe there are already some lines there included. So those are the ones that are
Yep.
in the README file. Okay. Then I want to ask you about why is important, or in which sense it's a bad thing to have this package dependence inequality.
Yeah, so in one sense, it's good because every ecosystem should have a strong and relatively stable core. And so that is a good thing that ROS has done. They've clearly been successful in attracting talented developers who can contribute this complicated code that works and that people feel comfortable relying on. But on the other hand, it is sort of dangerous over time as the ecosystem grows and becomes more complex to have you know, so much of the important code concentrated in a small set of packages, just because, you know, ecosystems age, right? Like whatever robotics development looks like now, it's going to look different in 5 years, it'll look different in 10 years, et cetera. So ecosystems need to be dynamic no matter what type of software you're talking about. And when you do get these clusters of important packages, you know, you have a set of maintainers, but they don't maintain forever. Eventually, maybe they'll stop or they'll leave. And so ecosystems suffer knowledge loss, and these groups can sort of become a bottleneck to the expansion and growth of ROS if other new things don't sort of come along to strengthen and replace them over time.
And do you think that this is something that may happen in the close future, or that is something that still is not going to happen in the close future, due that ROS at the end, it only has about 11 years, I'm not sure, 11, 12 years of age. So what is your opinion about that, based on your experience with the other packages? Because I know that I have seen in your paper, you are comparing this with other package open source projects. So what is your opinion on that?
I think for now, it seems like the community is very active. You know, like the founders of ROS are still there, kind of Tullyfoot's just like doing everything, you know.
Yes.
But yeah, those people are still there and they seem to be very dedicated for now. I would say probably like maybe in like 5 years or something, you might start to see issues. But yeah, I don't know. I mean, there are already a lot of abandoned ROS packages. There was another paper someone wrote a few years before ours just about package abandonment in the ecosystem, and sort of people just, you know, adding
I've read
packages
it.
to the distro and then not maintaining them. So that's always a worry. But part of the thing is like, well, what stays in the distro? There's a lot of packages in there that like like I saw one that was like it just said move from Google code and no one had touched it in like 5 years.
Yeah.
So it's like stuff like that. Why is it even in the distro? Some of it is just like you need to sort of trim the stuff that doesn't need to be there at all.
Yes, I do agree. And sometimes they are even very important or interesting packages that people are using that they don't get renewed for the next distro. And we are suffering at the construct this problem because we provide courses. I don't know if you know about our company, but we provide courses which are based on practice. So we are teaching, for example, how to do object recognition system, but there is no specific package like MoveIt for grasping or I don't know, the ROS navigation stack for navigation. There is no one standard for object recognition. So we are using several packages, but then as we have to upgrade the course to the next distro, then it looks, so it happens that those parts of the course cannot be done in the same way. So they have to be renewed completely and search how can we do this with, for example, with ROS Noetic, which is the latest one. And then we have to or take this out or find new ways or put a lot of our effort into developing something that more or less works. So I can understand your point on this. We are suffering in our own, yeah, so that's it. And then let me see here. Yeah, so one of my concerns about this low level of dependencies on other packages is I was thinking, okay, reading your paper, and then I say, okay, maybe could it be that this low dependency is because of the way that ROS is being structured, because it's structured as a set of packages that have nodes, and actually each one of them, they can be independent and then talk to the others. So for example, let's say we have a robot that needs to navigate and grasp things and recognize people, then you would have one set of packages, which is the navigation stack, which only depends on, let's say, on the ROS core. And then we have the MoveIt also for grasping. Do you know about the MoveIt package for grasping? Yeah. Then this also by itself, it only depends on the ROS core. Let's say, I don't remember, okay? But let's say, so, but they can work together without sharing any more dependencies than the basic ROS core. And all the other applications on the robot, they are behaving the same way. So what do you think, based on your results, could it be that one reason, or doesn't make any sense, this?
No, what you're saying makes a lot of sense. That people want to come and like grab pieces and put them together, and that's how ROS is structured with the pub sub architecture. But like, yeah. So the thing is, like, one thing we talked about is sort of just like the stages of an ecosystem, right? So when an ecosystem is new, there might be a lot of packages like that are going to directly depend on the core. But over time, you expect, right? It's almost like layers. There would be the first layer that all depends on the core. And then like what you said, you take all those pieces, you put it together and you create something new. And so these are just layers of abstraction developing within an ecosystem. And you'd expect that as an ecosystem matures, it starts to do that more. And you see secondary levels of dependence on the core or the foundational working groups. And so we haven't really seen much of that yet. Even looking at, we scraped like about 200,000, we call them client packages. So these were packages created by various users that weren't actually released as part of the ROS distro. So we assume these are like, actual robots people are building on top of ROS. And even in those, we didn't really see too many external dependencies. When they did exist, almost 90% of the time, over all 3 years that we studied, they were within the same organization, which we thought was kind of interesting. So like, if you do have a dependency, it's very likely to either be the ROS core or another package developed by your
Okay.
institution. Yeah. So,
Okay. Interesting. Interesting. And then, based on your experience on that subject, do you think that this is, well, I have understood, you think that in ROS, having this kind of behavior yet means like we are moving slow compared with other open source project. Is that one of your conclusions?
maybe I would just say ROS is in its early stages still.
Okay.
And you know, again, like it's really hard to compare with other ecosystems because the end goal of ROS is so completely different, and there's really almost nothing like it. You know, like we compared with PyPy and Julia, but it's not like there's another sort of similar open source middleware framework that we could look at. So, I mean, it's really impressive that ROS works at all, you know, given like the complexity of the project. It is like, it's hard to get open source robotics projects that are functional and that people want to depend on. But yeah, I think like moving forward for the ecosystem to really mature and become sort of polished and, you know, higher quality, higher security, you hope to see like secondary levels of dependence instead of primary ones.
Okay. So we have to work on that. ROS developers listening to this podcast, so pay attention to that. So if we want ROS to become better, stronger, and more widely adopted, then we have to work on this. So how many are raising their hands for that? Let us know in the comments. Or let Sophia also know. You can contact her. Then what about this? Another question is, so yeah, so based on how you have compared other open source projects, so how do they solve this problem, or they never had this problem in the first place?
Yeah, that's so okay. This is a yeah. So most ecosystems do, to an extent, have issues with this. You know, it's like a common thing in ecosystem studies to find power laws wherein 20% of the group is responsible for 80% of the outcome. But I would say the real thing that ROS has an issue with that other ecosystems don't is this discrepancy between the packages you're actually using and the ones that you've specified a dependency on. So, you know, as we said earlier, you can have, you know, you can have packages installed in your system workspace that don't show up anywhere in your package.xml file or even in your project workspace. And then as soon as someone takes that project and tries to run it, they don't have those packages installed, right? They get an error. So this is something that a lot of other ecosystems will not allow you to do at all. They'll say, you know, if it's not specified anywhere, you can't run it, like, sorry. And I think ROS could benefit from, you know, some sort of structure like that. Or another thing that a lot of other ecosystems do that sort of helps them manage their evolution is just adapting a very clear versioning policy. So semantic versioning, I know Tullyfoot's been in like the ROS discourse trying to get people to do it, but I don't think it's fully caught on yet. So yeah, that would be really useful. And maybe even there is right now a way to specify the version you depend on in your package.xml file, but we found that less than 2% of dependencies actually, yeah, it's really uncommon. And a lot of other, like NPM, for instance, forces you to say what version of a package you've depended on. And so for, you know, someone else going in to use that project, it's a lot easier to know what you need to install. So yeah, those are a few things that might help make the ecosystem a bit more robust going forward.
Okay, so I have to tell you that your paper and your explanations on this, so they have influenced our company in that specific sense, in the good sense, because so while I was preparing this podcast interview, then I saw this problem because myself I'm doing this, so I'm doing all those things, all of them. But then we have in our case we have an opportunity to teach the new guys, the new ROS developers, because we are teaching the new guys that become ROS developers, so we can put this as a requirement, you know, like a good practice from the very beginning when they are starting to learn. So we are going to modify our courses to enforce this. So it's work that we are going to develop along this year. But I wanted to tell you that thanks to your paper and especially to your talk, that at ROSCON that we are going to take those actions. So your work was useful in some sense.
Wow, I think that's like the first time anyone's told me that. So
great.
Yeah.
So I will let you know about the evolution of this. Okay, we'll see.
Awesome.
So it's like putting so you have put your small part into to improve ROS, right? And then we are going to do our part. Now we are going to carry your small part into the others, and let's see what happens. Let's see. Okay.
Hopefully it makes a difference at some
Yes.
point.
Yes, let's hope that. We'll see. Maybe next ROSCON we can see here explosion or whatever, you know.
Everyone starts specifying their dependencies.
Yeah, exactly. In the versions and the version.
Yes.
And okay, so so you have answered a couple of questions already. Then let's go to a very important point. So your analysis was based on ROS 1, let's say ROS 1, ROS kinetic. And so what do you think about ROS 2? So in ROS 2, you know that it have just a few years of life, and actually only recently in the last couple of years that has been improving really to be really useful. And do you think that this is a new start of the same thing? So we are going to go to the same thing, and then in 11 years of ROS 2, we are going to be on the same situation right now? Or do you think that this is going to change? So it's going to take the experience of the ROS 1 in this aspect, in this specific, and make better ROS 2 in that point?
Yeah, so from what I've seen so far, it seems like the consensus is that ROS 2 is more secure and of slightly higher quality.
Mm-hmm.
And yeah, as far as I know, ROS 2 still uses the same package management system and does not have semantic versioning. But I mean, it does seem to be of slightly higher quality. And so, you know, it is a step in the right direction. And, you know, maybe there will be a ROS 3 in 11 years. Who knows? But I think it's definitely a good milestone to sort of, you know, acknowledge that there were some, you know, questionable things in ROS, and then, oh, we want to try and fix them and keep evolving. But one of the best things I've seen in some ROS 2 packages is just people actually giving ROS install files that allow them to specify their versions and whatnot. So that's a good thing that has started to crop up. So yeah, I mean, I think it's just a gradual process of, you know,
well, in ROS 2, they have created this thing that are called the working groups, which are set of companies, developers, institutions that they have to be accepted into those working groups. So let's say I want to be on the working group about security in ROS. And then they are in charge of the development and the improvement and the evolution of the security stuff, the security packages or environment for ROS 2. And this is divided between several working groups. So maybe that could help to prevent that everything is under open robotics. You know, so they cannot manage because I mean they have limited resources. But by dividing into this, then more people can keep maintaining more important packages, so people can depend on them. And then
I think it started out in ROS as they had special interest groups at one point, and then these sort of evolved into what is now like all of the ROS dash groups, like ROS perception, ROS simulation, ROS controls, I think is one. And yeah, so those were sort of like people who came together around a topic in robotics and had expertise in that. And, you know, I think that's part of why those packages are the most used, because they've recruited, these people who are really passionate and really talented at like working on this one thing. And that's sort of like how you manage, right? Like the person who builds the perception stack isn't going to do the motor controls. You know what I mean? Like it's a good way to sort of divide and conquer. And it's been really successful in ROS, but it was never something that was explicitly listed anywhere. Like you can't go to the ROS website and, for ROS1 and like sign up for these things. It's sort of just something you come to realize as you start getting familiar with the ecosystem. So I think it's really good that ROS2 has sort of acknowledged this and gone out of its way to, make these groups a focal point of the ecosystem, because that is, from what we've seen in ROS, ROS1 or ROS, whatever, that does seem to be like the most successful way to conquer this task of, building the whole ecosystem up.
Okay. We'll see. Let's hope that is in ROS2 is better program, and then we don't have this dependent inequality in such a large grade, grade, I would say. Then I don't know how to ask you this. So about what is your conclusion about how the ROS ecosystem is growing? So do you think it's healthy? Do you think it's okay? Yes, in Spain we have something to say to the students, that it says it progresses adequately or good enough. I don't know how to say in English. So it's good enough progressing, but that's usually when you want to say to the student, okay, if it was for me, I would put you down, but I cannot. So, okay, progresses more or less. Then this is good or is it bad? So what do you think about that?
Yeah. So maybe I'll try and be more numerical, but we basically just compared the growth rate of the distro and the client. So again, like the clients are just all of the random ROS packages on GitHub. And the distro is growing at a linear rate similar to PyPy and Julia, the two ecosystems we compared it against. So that seemed to be healthy. It was almost growing at the exact same rate as Julia. And with the client packages, there was exponential growth. So, it seems like a lot of new people are continually being attracted to ROS and building new stuff. So that is really promising. And it seems like ROS is actually growing at a healthy rate. The one sort of thing I will say is that we also broke down the parts of the ecosystem into the major contributing groups. So we have the working groups, the core, companies, academic institutions, robotics teams and stuff. And we sort of analyzed all of the groups in the distro by these categories. And we found that companies are actually the fastest growing part of the ROS ecosystem as of now. They're contributing the most packages. But in terms of actual dependencies on packages, these working groups that we talked about, these are like the most, like, ROS dash whatever. These are really the fastest growing in terms of actual use. So, and then we looked at how quickly these groups are getting new maintainers and new developers. And there's only, I think, been one person added to any of the groups since 2019. So there are people who aren't actual members contributing, but in terms of the real core maintainers of these foundational groups, they're kind of stagnating a little. So that is something that, to be conscious of moving forward.
Yeah, okay, I understand your point. And so here, so I don't know if that's, so this single person that has been added, it could be related to the ROS2 distribution. It could be due to that, because I don't know if you're aware that ROS Noetic is the last ROS1 distribution that is going to be released. So for the next year is only going to be people working on ROS1. It's about fixing bugs and doing maintenance of the packages until this ROS Noetic ends its lifetime. But the main core, the main energy is being put into ROS2. So that what I mean with that is that I don't know the answer, but this specific situation that we are living with ROS1 and ROS2 is kind of making more difficult to make this analysis.
Yeah.
So I don't know.
Yeah, that's true. There could just be a lot of people getting added to the ROS2 groups.
I don't know.
Yeah, it's true, but you know, if you look at the graph, it's kind of just like, and it does stop a bit before. I mean, maybe the sort of like slowed growth correlates with the beginning of ROS2.
No. Hey, that's a very good paper for the next ROSCON. So you can do the same study for ROS too.
Yeah, that's a good idea.
Okay. No, I don't know. I'm putting this there on the table.
You can have a copyright of that idea.
No. Just for free. You are going to do it better. You're going to do it better than me. Then okay. So yeah, that's it. So all the other questions, they have been answered so far. So I have here some questions, but we have been answering in different situations. Just for the ROS developers there, that all those numbers that she has mentioned, they are included into the paper that she has published. So you can go to the paper and get the actual numbers and figures, because everything there that you mentioned right now about the clients and the core clients and what's the other word?
We call the foundational working groups.
Okay, and foundational working groups. So all this is presented and shown on the paper. So go there and read the paper. Really interesting. So that's it for today for this interview. So can you tell to people where they can find you to ask you questions, or in case that you don't want to be found, you can tell, hey guys, let me alone.
Yeah, so I have a Twitter at Kolak Sophia, but I would say the easiest way to get in contact with me is just to email me at sdk2147@columbia.edu. So
okay,
I'm pretty responsive to email, but I don't really check my Twitter.
Okay, great. Well done, by the way. And yeah, then I will put a link to your LinkedIn profile.
Okay, yeah.
And then I think that there is an email that, so you have provided an email, so they can, so instead of putting the email directly on the show notes, I will put a link to your LinkedIn, so people can go to your LinkedIn and then ask you for permission to contact you, and then you can decide. Yeah.
Sounds good.
Okay, great. So thank you very much, Sophia, for being here.
Thank you for having me. It was fun.
Yeah, let's hope that we will meet on the next ROSCON.
Yes.
Okay, with another ROS2 analysis paper.
Yes, hopefully.
Okay, thank you.
Thank you so much.
And for all the people there, ROS developers, let me tell you that we want to make these podcasts explode, and for that we need your help. So if you know somebody that may be interested, that is a ROS developer or want to be a ROS developer, please tell them about our podcast. Share this podcast, share the video on YouTube, share the link to the show notes, whatever, and help us increase this podcast and become a reference in the ROS world. And that is all for today. So see you next week with a new lesson from the experts. And until then, keep pushing your ROS learning.